So we're going to take a look at the review for test number 1. And in the first problem here, we want to estimate the x and y intercepts from the graph. And what you want to notice here is we have a horizontal line. In fact, this is the line y equals 3. So it does have a y-intercept at 3, but it doesn't hit the x-axis. So there are no x-intercepts. So they tell us here to write each intercept as an ordered pair, separate your answers using commas if necessary, select none if applicable. Well, since there's no x-intercept, we're going to say none for those. For the y-intercept, this is occurring here at y equals 3. We have to write that as an ordered pair, 0, 3. Make sure you do write it in as an ordered pair. Make sure you write them in the coordinates in correct order. The x-coordinate first and then y-coordinate. Number 2, we're doing the same thing. Here we have one x-intercept at -3. But then we have two y-intercepts, one at 2 and one at -1. So for the x-intercept, I'm going to write that as -3, 0. For the y-intercept, I have two of them. I have one at 2, so I'm going to write that, and one at -1. So I'm going to write that as 0, -1. And it says separate your answers using commas, so we'll put a comma. And the other one is 0, 2. And again, make sure you put it as an ordered pair and make sure you have them listed in alphabetical order. X-coordinate first and then y-coordinate. For number 3, we'll suppose that H's relation is defined as following. So H is this ordered pair, 7, 9, -5, 1, 7, 0, and then finally 5, -5. And it asks us to give the domain and range of H, and want to write your answers using set notation. So remember, the domain, when you got a set of ordered pairs, is going to be the x-coordinates, the first coordinates of each point. So I have 7, -5, 7, and 5. So I have to have them twice. I'm not going to write that down twice. So by the way, this would not be a function, but it's still a relation because we have a value of x going to two different values of y. So I'm going to put these in numerical order. So -5, 5, 7. And that would be my domain. Just listing the x values. If I have any repeats, I'm only listing them once. For the range, we're doing the y values, so we have a 9, 1, 0, and -5. So again, I'll put them in numerical order, -5, then 0, then 1, and then 9. Let's take a look at number 4. And number 4, we want to find the x and y intercepts. So let's first do the x-intercepts. And to do that, remember, whenever we're looking for an intercept, we always set the opposite variable equals 0. So I'm going to set y equals 0. So I take my equation, y is 0. That gives a -3x equals 18. I'm going to go ahead and divide by a -3 to solve this. And that's going to give me x equals -6. So for my x-intercept, it's the point -6, 0. Again, they're telling us to write it as an ordered pair. So this Alex loves ordered pairs. Do not just write -6 as the answer. It will count it wrong. So let's go after the y-intercept. So this time we're going to set x equals 0. And we're going to solve for y. So that gets us a -6y equals 18. I want to go ahead and divide both sides by -6. And that's going to give us y equals -3. So I'm going to write that as an ordered pair, 0, -3. The next problem, we want to determine if this relation defines y as a function of x. So here, when we got a graph, we're going to use the vertical line test. And any vertical line here I take passes through at most one point. So this relation would be a function. So I would put yes. This relation defines y as a function of x. If we were to look back at problem number 2, this graph would not define a relation as a function of x, because if I draw a vertical line right here, I pass through more than one point. So problem number 2 would be an example where this would not be a function. So let's turn the page. And we want to determine if the relation defines y as a function of x. And the answer here is no, because I've got an x value that's going to more than one y value. In fact, if I were to plot these on a graph, if this is my graph here, I'd have 3, 2, I'd have 3, 8, I'd have 3, 9, and 3, 6. Those are all lining up on the same vertical line. So the answer would be no, this relationship does not define y as a function of x. Looking at number 7, we want to evaluate the function h of x equals 4x squared plus x for the given value of x. Simplify your answer. So they want us to find h of negative 4. So that means wherever we see an x value, we're going to plug in negative 4. And now follow your order of operations. You can do this on your calculator if you want to. Negative 4 squared is 16. 16 times 4 would be 64. And this becomes minus 4. So our answer would be 60. Let's try number 8. We have k b minus 2, and our function is k of x is x squared plus 2x. So let's just kind of write out, whoops, my bad. Should be x squared plus 2x, and this time replacing x by a b minus 2. Now, since we have more than one term inside this parentheses, we can't just square each term. We have to go through and FOIL this out. So let's go off to the side here to our scratch paper. So SP for scratch paper. I'm looking at b minus 2 quantity squared. That's equal to b minus 2 times b minus 2. We're going to FOIL that out. Product the first would be b squared. Outer terms would be a minus 2b. Inner terms would be minus 2b. Last terms be a plus 4. So this is going to simplify to b squared minus 4b plus 4. So let's put that in. Next, I need to go ahead and distribute that 2 to both terms here. So that gives us plus 2b minus 4. And now we just combine like terms. B squared is by itself. Negative 4b plus 2b is a negative 2b. And 4 minus 4, those add up to 0. This simplifies to b squared minus 2b. Let's try number 9. It says determine the domain and range of the function. So we're looking at this graph. Remember that this open circle means we do not include that point. So for domain, we're going from left to right. Going from left to right. This thing starts after -3, so I can have a parenthesis at -3. This arrow means it goes on forever, going from left to right. So my domain here is going to be from -3 to infinity. Let's do the range. The range from bottom to top, my first y value here is 1. I include 1. And again, this arrow goes on forever, so it goes to infinity. So I'm going to use a square bracket since I actually do want to include that 1, because that line hits right at y equals 1 to infinity. Let's go and turn the page and take a look at the next one. All right, here's another interval. So for the domain, here this time I'm starting right after -4 and going left to right. This arrow means it goes on forever, so that's going to go out to infinity. So my domain here would be -4, infinity. My range, well, this arrow means it goes on down forever, so going from bottom to top, going from -infinity up to and including 3. Now you have to remember the correct order to write this. Negative is always written from smallest to largest, so I have to write the -infinity first. And then we're going up to 3 and include 3. All right, let's take a look at number 11. Again, we're doing a domain and range. These arrows means it continues on forever in both directions. So going from left to right, my domain is going to be all real numbers. So that's going to be -infinity to +infinity. For the range, I'm going from the bottom to the top. The first thing you hit on the bottom is 2. I'm sorry, 0. At this point, 2, 0. So this is the y value 0. So this is my y value 0. And then it goes on forever. So my range is going to be 2, and I'm going to include 2 to I'm sorry, 0. I don't know why I'm stuck on 2 today. Let's try that again. That should be a 0. Because my y value, first y value here is y equals 0. Probably shouldn't be recording this at 4:30 in the morning. So that would be our range. Number 12, if you remember, I did ask you to make sure you have these graphs memorized. So from memory, match the equation with its graph. So the absolute value, that is a V-shaped graph. So look for the V shape. And that would be option D. G of x equals x squared, that's our parabola. Okay, there's our option A. H of x, that's our x cubed, so that looks something like this. And that would be E. P of x equals the square root of x. It's half a parabola turned on its side. So that would be graph B. Cube root of x kind of looks like the square root, but then it has this other piece over here. So that would be F. And then 1 over x, well, it's this one here is the one that hugs the axis. That would be C. Now on the actual test, you might have a problem like this. It might be where they give you the graphs, and then it's like a mix and match. You'll have to grab each of the functions and match it to the corresponding graph. Let's take a look at number 13. Use translations to graph the given function. So our parent function here is the square root function. So let me just kind of draw it over here, just so we have a reference to work with. And mark some points here. This is some points that we've already memorized. Okay. Now this plus 1 is going to shift it up 1. So I'm looking at that point 0, 0, adding 1 to the y coordinate. That becomes 0, comma 1. 1, 1 shifted up 1 becomes 1, comma 2. Excuse me, 4, comma 2. Excuse me. Shifted up 1 becomes 4, comma 3. And then we just go ahead and sketch in a graph. Let's try number 14. Here we have the absolute value of x. What we're doing here is we're taking our absolute value function, or v function. Let me just draw it over here. That's our parent function. Again, I'm looking at some points here. And then at minus 5, that's inside the absolute values. So that's a horizontal shift in the opposite direction. So it's going to shift 5 to the right. So 0, 0 is going to go to 5, 0. It's like I'm adding 5 to each of my x coordinates. Negative 1, comma 1. It's going to go to 4, comma 1. 1, comma 1, shifted 5 units to the right, becomes 6, comma 1. And then we're just going to draw in our v-shaped function, absolute value. And that would be our graph. I think, Alex, it's going to have you actually just pick up the function and shift it where it needs to go. So here we have our cube function, and this one's shifted up 3. So think of our cube function. That's why we should know what these shapes look like. That's why I asked you to memorize them. And we're going to kind of follow some points. Now all these points are going to be shifted upwards 3. So the point 0, 0 is going to go to 0, comma 3. 1, 1 is going up to 4, 1, adding 3 to each of the y coordinates. Negative 1, 1 goes up 3. These again are kind of like my anchor points, so I'm kind of sketching my graph from here. So it's going to look something like that. All right, let's take a look at number 16. So we are playing with our square root function again. So let me just draw it over here. Again, just following some points here. And let's see what happens here. Well, this 2 here is our horizontal shift, so it's going to be shifted left 2 and 4 downwards. So it's like I'm subtracting 2 from the x coordinates and subtracting 4 from the y coordinates. So 0, 0, I shifted left 2, down 4. Point goes right there. 1, 1, shift left 2, down 4. Goes down here. And then 4, 2, shift left 2, down 4. That goes here. And then we just start sketching our graph. All right, number 17. The function g is given. Identify the parent function. Then use the steps for graphing multiple transformation functions to list in order the transform is applied to the parent function to obtain the graph g. Now this book, Alex is very particular here in this problem. You need to follow the orders of the transformations. If you put the transformations out of order, it's going to count wrong. So first of all, we look at our function. We have a squaring function. So our basic function, it's got to be the quadratic. So for part 1, that's pretty easy. I'm just going to type in x squared. Now for part 2, they want us to do the horizontal translation first. So that's a negative 6.2 inside there in the parentheses. So I'm getting the opposite direction. I'm shifting right 6.2 units. So write that down here. All right, and then next we want to look for a horizontal or vertical stretch. Well, this is shrunk vertically by 1/5. So we first did this one because that's our first step. Now I'm taking care of the horizontal stretch and shrink, or vertical stretch and shrink. In this case, it's a vertical stretch or shrink. And then we want to do the vertical shift. So that would be this one here. And that's going to be 7.2 units upward. All right, so let's go and fill in the blank. So for blanks 1, 3, and 5, these are options. So in that first one, we add a shift. So I want to put in shift. The graph of f, then my blank 2 and 4, 6, here are my options. We said to the right 6.2 units. Next one, we shrunk by 1/5. So for blank 3, I want to select shrink. And then vertically by a factor of 1/5. And then the last ones, we shift 7.2 units upwards. So I'm doing a shift. And then I would go down here and select upward by 7.2 units. So again, just make sure you do it in the correct order that they're indicating you to do up here. We had no reflections across the x and y axis, so we were able to skip step number 3. Number 18. So we have the graph of f and the graph of g. So f is the blue solid line, G is this dashed red vertical line here that's dashed. And so for problem 1, down here, f of 1, when x equals 1, I'm looking at the point on the blue graph, or the solid line, and my y value is 1. This is my x value, and I'm just reading off the y value. So looking at f of negative 4, it goes down to this point here. I'm reading off the y value, that's negative 3. Now let's do g. G of 0. So now I'm looking at the red graph. So when x equals 0, I'm looking at this point up here. My y value is 4. And then g of negative 3. So looking at when x is negative 3, going up to my dashed graph here on g, my y value is 4. So both of those are 4. So I'm just using the graph to read off basically what the y values are when on the various graphs when we're given the x value. Let's try number 19. So we're given some functions. F of x equals negative 7x, g of x equals the absolute value of x minus 4, h of x equals 1 over x cubed. We want to evaluate the function g minus h of 4 for the given value of x. Alright, so now remember what this notation means. This notation means g of 4 subtract h of 4. So let's first find g of 4. So remember what those absolute values do that. If we work out the problem, whether that number is positive or negative, it's going to make the answer positive. So we're going to plug in 4 minus 4. That gives us the absolute value of 0, which is just 0. Alright, so that was actually pretty boring. Now let's calculate what h of 4 is. So we're going to replace x by 4 in our h function. 4 minus 3 is 1. 1 over 1 is 1. So this is now 0 minus 1. So that's going to give us a negative 1 for an answer. Let's try number 20. So here we're doing composition. So remember what this notation means. This means f of h of negative 1. So let's first go off to the side here on scratch paper. Let's figure out what h of negative 1 is. So I'm just going to plug in negative 1 to my h function. That's 7 times the negative 1 is negative 7 plus 8. That gives me positive 1. So this inside of here, h of negative 1 becomes 1. So now I'm just looking for f of 1. So I go back up here. Here's my f function. Go ahead and replace x by 1. That's 1 plus 6. And that's going to simplify to 7. So 7 would be our answer.